Hi, for this recording, I will show you a creative application of comparison test for infinite series. We know the series 1 plus half plus 1/3 plus 1/4 plus 1/5 plus 1/6 and so on is a divergent series. And this is because it is also a p-series, also known as a harmonic series. Now, we also know that if you change a little bit, say 1 minus half plus 1/3 minus 1/4 plus 1/5 minus 1/6. You notice that this term is an alternating series as the term become positive, negative, positive, negative. We also know that this series is convergent, and the test we use is called an alternating test. You can refer to David Brannan analysis text, page 106 for the proof. Now, what about the series 1 plus half minus 1/3 plus 1/4 plus 1/5 1/5 minus 1/6 plus 1/7 plus 1/8 minus 1/9 and so on. So every third term you become a minus sign. Is it convergent or divergent? I'm going to apply the comparison test to investigate the series is convergent or divergent. Hey, but you wait a minute. How do you apply the comparison test? Isn't it the comparison test only for series with non-negative terms only? But now we have a minus 1/3 in the third term, minus 1/6 in the sixth term, and minus 1/9 in the ninth term. So in this case, we are actually using the comparison test very creatively. The trick is below. 1 over 3n minus 2 plus 1 over 3n minus 1 minus 1 over 3n is greater than 1 over 3n. Why? First of all, we know that 1 over 3n minus 2 is greater than 1 over 3n. Therefore, if you add both sides by 1 over 3n minus 1, so you add both sides 1 over 3n minus 1, this is still whole. Then I look at another inequality. 1 over 3n minus 1 is greater than 1 over 3n. So if you add both sides by 1 over 3n, then this inequality will still hold. Therefore, in the end, what we obtain is this 1 over 3n minus 2 plus 1 over 3n minus 1 is greater than 1 over 3n plus 1 over 3n. So if you subtract 1 over 3n from both sides, you got this inequality. Alright? And why is this useful? So if we let an equal to 1 over 3n minus 2 plus 1 over 3n minus 1 plus 1 over 3 minus 1 over 3n, what will happen to an? You notice that a1 is for n equal to 1. You get 1 over 2 plus 1 over 1 plus 1 over 2 minus 1 over 3. a2 for n equal to 2, you get 1 over 4 plus 1 over 5 minus 1 over 6. a3, when n equal to 3, you get 1 over 7 plus 1 over 8 minus 1 over 9. So if you sum up the an, summation of am is ready. 1 plus 1 over 2 minus 1 over 3 plus 1/4 plus 1 over 5 minus 1 over 6 plus 1 over 7 plus 1 over 8 minus 1 over 9. This is actually the series we're investigating, whether the convergent or divergent. Now let's Bn be 1 over 3n, the series we are going to make in reference. We know that an is greater than Bn now. from our inequality, we know that an is greater than bn, right? In our both inequality. So now, because an is greater than bn and bn is non-negative, so all the terms are non-negative now. So these are all non-negative now. And since the series Bn is summation of 1 over 3n, and we know that this is a divergent series, so by comparison test, which is in David Brannan book, page 94, the conclusion is summation of an diverge. That means the conclusion is a series which is summation of an is 1 plus half minus 1/3 plus 1/4 by 1 over 5 minus 1 over 6 and so on is a divergent series. This is the end of the recording.